Hello everyone, welcome to Plus2, and in this series I will be describing different physics topics one by one. So in this particular video I'll be talking about electrostatic charges. So this is a beginner's introductory lecture on electrostatic charges. So let's start. So I'll just put the heading as electrostatic charges. Okay, so today we'll study electrostatic charges. Now what is electrostatic charges if we start, because whenever we study a topic we should know what is it all about. Electrostatics is the study of electrical charges at rest. So there are two terms which is important. One is charge and the other is rest. Now remember that if we have a charge, let's say a positive charge, and it moves with some velocity or acceleration, then it constitutes a current. Now that is a separate topic in physics, and we are here focusing only on electrostatic charge. So static means which is not moving, and charges means charge, that is positive, negative or neutral. So basically electrostatic charges is also known as static charge. So the other name is static charge, and there is one more name which is also known as frictional charge. So electrostatic charge is known as static charge, and sometimes it is also known as frictional charge. Okay, so the charge at rest are produced due to friction between two insulating bodies when they are rubbed to each other. Let's say I have a piece of cloth. Okay, so this is a cloth, and imagine I have a glass rod. Okay, so when you rub this to each other, what will happen is the rod will acquire some charge and the cloth will acquire the opposite charge. You must have seen the example where small pieces of paper get attracted towards a comb, right? That is due to the same phenomena I discussed here. In this example, you will see that when you rub your head with a comb and then you place that comb near a piece of paper, you will see the paper will get attracted to the comb. Similarly, if you scratch a silk with a glass rod of different nature, the two rods might acquire different charges, and they might repel because the two rods have the same charge. And if one of the rod is placed near the cloth, and if they both has different charges, they will try to attract one another. So now let us try to understand what are the applications of electrostatic charges. So why are we studying this topic? So what are the applications of electrostatics? So number one is the prevention of pollution of atmosphere by electrostatic precipitation of fly ash. So this is basically precipitation. So in this case what happens is, so let's say you have a factory and there is a chimney, okay, and smoke is coming out from that chimney, right? This is a typical scenario of a factory. Now what happens is that the smoke is charged using the principle of electrostatic, and then it is passed through two charge plate, one positive and one negative. When the smoke is passed through these plates, so if the smoke is negatively charged, then it will go towards the positive side. If the smoke is positively charged, then it will stick to the negative plate and then it will precipitate. it means that it will just accumulate and form a residue or solid which you can take and throw it somewhere else. So this is one application of electrostatic. The second application is in designing electrostatic generator like Van de Graaff generator. So probably you will study that in Van de Graaff generator you can generate very high volt. Say for example, if you have a 100-volt source, you can generate up to 10,000 or higher volts. Now this high voltage might be useful in some scientific research or in some of the experiments. And let's talk about the third application. The third application is electrostatic spraying of paint powders. So if you see this image, you see that we have a gun, and what this gun can do is it can create small droplets of negatively charged spray paint, right? And let's say the wall is positively charged, so the negative charged spray will stick to the wall and it will help to make spray paints. So the third is spray paints. What is the fourth application? Now in fourth application we have printers. So we all have seen printers, right? We use it to print photos or text or projects. Now how this work is, it use electrostatic technologies to print the colors. So what basically how it work is, they have ink cartridges and it is computer like it is being programmed using computer code and circuit board that there is some electrostatic force and the ink get diverted to particular location in the paper depending on the color and the information. So as you can see, this paper, this region is orange, so the electrostatic force act in such a way that the color yellow or blue will reach the particular position in the paper using electrostatic physics. Okay, so the fourth application is in printers, and the next application I want to talk about the cathode ray tube and similar application. You don't have to understand this complicated diagram, but just remember that in old TVs you must have seen it looks very bulky, right? Something like this. So what this contains something like this. This is known as cathode ray tube. So how this work is, they have plates which contain charged plates, and electron beam is being pumped through here, and depending on the charge of the plate, the electron is deflected and we get the image. So the application, this we have cathode ray tube, and the final that we all know is the lightning, right? So in a rainy day, if you are standing and there's a lightning in your head, you will probably die, because these are very high voltage current beams which can ionize anything because the voltage is very high. So this is not an application, but basically a feature of electrostatic. So let me just recap once again. The first is precipitation, which is used which could be used in factories to reduce pollution. The second is Van de Graaff generator, which can generate high voltages. Third is the use of spray paints. Fourth in printers. The fifth in cathode ray tubes, and the last in lightning. So these are the applications of electric charges. Now let us understand what is electric charge. Now we understood what is electric charges, but what is actually a electric charge? what is a electric charge? So how can you answer this question? So electric charge is a characteristic that accompanies fundamental particle wherever they exist. So whatever elementary particle you have, let it be electron, proton or neutron, in its elementary form it has to have some kind of a property called charge. We know that electron is negatively charged, proton is positively charged and neutron is neutral, but it is basically a combination of positive and negative charge, which we study in higher classes in physics. So this is the fundamental nature of electric charge, that any particle in the universe which we all know of, in its fundamental terms contain positive and negative charges, right? So if the object, let's say I have a box, right, if it has more positive charge than negative charge, that means the object is positively charged. If it has equal positive and negative, then it is neutral, and so on. Now let us talk about the kind of charges. So how many kind of charges do we have? So it is quite well known, and we all know that there are two charges. One is negative charge and the other is positive charge. Just like there are negative people and there are positive people, and there are neutral people as well. Similarly, we have negative charge and positive charge, and if any object contain negative and positive in equal amount, then it could be neutral, right? But in general, remember that charges are of two types, that is negative and the other positive. So I will end this video here, and in my next video I will go a little bit deeper on electrostatic charge. We will study the origin of electrostatic charge, and then we'll go one by one. If you like this video, do give a like and leave a comment how I can improve my video. Thanks for watching and take care.